right, lesson 1.4, geometric series. If the terms of a sequence are added up, the result is called a series. So I'm going to prove to you how they get this formula, and we use the previous formula for just adding up. An unlimited amount would be term 1 plus term 1 times the ratio, which we learned the other day, and then of course term 1 times the ratio squared for the third term, etc., etc. If I take this same statement and multiply it by r, I get rsn on the left side, and then I multiply all the r's on the right side, and I get the second statement. Now if I subtract, on the left side, I get Sn minus Rsn. So now, if we take this and we subtract, you see these will eliminate, these will eliminate, all these will eliminate, right? And the only thing that I will have left is T1 subtract T1 r to the power n. Now, if I factor out an Sn, I'm left with 1 minus r. If I factor out a term 1, I'm left with 1 minus r to the power n. And then if I do divide, I get that Sn is equal to term 1, 1 minus r to the power n, divided by 1 minus r. So that's the formula that's here, and that's where it comes from. All right, so let's try the formula in the first example. So it says find the sum of the first 12 terms for the following sequence. 5, negative 10, 20, negative 40, dot, dot, dot. So if we're finding the sum of the first 12 terms, that would be n equals 12. They give you that the first term is 5. Now, in order to calculate the ratio, we would take the second term, which is negative 10, and divide by the first, or the third divided by the second, etc., etc. So I get negative 2 as my ratio, and then we just plug it in. So S12 equals the first term, which is 5. 1 subtract, and you got to watch, because the ratio is negative, you need to put the negative 2 in brackets to the power 12, and then that is 1 subtract negative 2. All right, so you can simplify, or you can plug it all in. Sometimes I like to simplify before I mention my calculator. So I get 5, 1 subtract 4,096, divided by 3, and then if I just punch that in, I get negative 6,825. Next example, given the sequence 81, negative 27, 9, negative 3, find S6. So they're giving you that you're finding S6. Here's your first term, and then my common ratio would be negative 27 divided by 81, which reduces to negative 1/3. So then I'm just going to put it into my calculator. Well, first I'll write it out. S6 equals 81. 1 subtract negative 1/3 to the power 6 divided by 1 subtract negative 1/3. Now watch when you're putting a power to an even, if you type it into your calculator wrong, you'll get the wrong answer. So my advice to you is to use your common sense. If you have a negative to an even power like you do here, you should get a positive. So you may want to do it on your calculator first, using the fraction key, or you can just do 3 to the power 6 and put a 1 over it, because you know that 1 to the power 6 is 1. So I get 81, 1 subtract 1 over 729 divided by, and then 1 subtract 1/3 is 4/3. So if you punch that all in, you get 182 over 3. Okay, so we should be using fractions and not decimals, because the decimals, you should not be rounding. I guess if you leave it as a decimal that with that you indicate the actual irrational number, that will be fine, but it has to be the exact value. All right, so here it says, what is the sum of the first 10 terms? So we're finding S10. We have the first term. The ratio, I have to calculate 6,400. That's the second term divided by the first term, which is negative 12,800. And that reduces to negative 1/2. So S10 would equal negative 12,800, which is the first term. 1 subtract negative 1/2 to the power of 10. Again, because this is the power of 10, that means you're going to get a positive out of that, but you're still subtracting. So then 1 subtract negative 1/2. Again, because there's a 1 on top, 1 to the power of 10 is just 1, and 2 to the power of 10 is 1,024. So I'm going to rewrite this before I type it in the whole thing into my calculator. So it's 1 subtract 1 over 1,024, all divided by 3 over 2, is 1 subtract negative 1/2 is 3 over 2. And final answer, negative 8,525. This is actually a great question. You can even ask your parents about this one, and you'll astonish them. So here's the scenario. If you were to earn 1 cent on the first day, 2 cents on the day after, 4 cents on the next day, and keep doubling every day, how much will you earn in total? And you're going to add it all up. How much will you end in total at the end of 30 days? So first term is 1 cent. The ratio is doubling, so 2. We're trying to find after 30 days, so n equals 30. So we're finding the sum, because it asks for the total, is 0.01. 1 subtract 2 to the power of 30 divided by 1 minus 2. So punch that in, and you will be amazed how much that number actually is. $10,737,418.23. Pretty crazy considering you started with 1 penny to begin with. All right. Moving on. Example 5. Determine the sum of the geometric series correct to 3 decimal places. I'm actually, we're going to do exact values here. So I'm not going to say correct to 3 decimal places. Anyways, so the problem here is I don't know what term 5.46875 is, so I need to determine that first. I do know that term 1 is negative 700, and the common ratio is 350 divided by negative 700, which is negative 1/2. So the first thing I need to do is to use the formula Tn equals term 1 r to the power n minus 1 to figure out what n is. I don't know what n is. Okay? So 5.46875 is equal to negative 700, negative 1/2 to the power of n minus 1. So now if I divide the 700 out of there, I get a negative 0.078125, and that is equal to negative 1/2 to the power of n minus 1. So it may be easier to change the 0.078125 to a fraction, and this fraction is 1 over 128. So we need to figure out what that is. Now, in grade 12, we learned how to solve for an exponent, but in grade 11, we are using guess and check. And so basically you need to figure out what would you give for 1/2 to get negative 128. And if you keep on going on your calculator, you get negative 1/2 to the power 7 will give you negative 128. So that means that n minus 1 is 7, which means n equals 8. Because these match right there, right? All right, so now I'm going to find S8. Okay, so that is negative 700. 1 subtract negative 1/2 to the power 8 divided by 1 minus negative 1/2. And if I push that in, I get negative 464.8437.5, which that's what I'm saying. It's not correct to 3. I'm going to do the exact value of this. All right, last example. The sum of the first 8 terms of a geometric series is 16,400. If the common ratio of this series is 3, determine the first term. So it's saying S8 is 16,400. So this is a working backwards problem. Gives you the ratio is 3. So if we plug it into the formula, Sn equals term 1, 1 minus r to the power n divided by 1 minus r, we get 16,400 equals term 1, 1 minus 3 to the power 8 divided by 1 minus 3. I simplify, I get 16,400 equals term 1 times negative 6560 divided by negative 2. So if we divide that amount out, we get that term 1 is